Before we can talk about transient detection systems, we first need to know what a transient is. And maybe you already know, but if you don't, we can consider it as a short-lasting, small section of sound. A brief peak that stands out from the rest of the audio. This could be the very beginning of a sound. And as you might imagine, parts of sounds, with more emphasis, how they start and decay, play a critical role in how we perceive them. Sharp spikes that jump out and grab our attention, or softer, more sustained pieces that carry behind. And oftentimes we may want to adjust this to correct or enhance an audio signal. And while it's perhaps easy to describe this feature, what are some ways we might go about engineering something to capture only this part of the sound? We might use a system with a threshold, like we've become accustomed to with dynamics processors. But one problem with this approach is it doesn't account for fluctuating average volumes. It may miss transients during quieter segments, so it would be more beneficial to have something that can isolate this region regardless of the signal's average volume. And how we might look to do that is through some type of differential signal. And a type of differential measurement you may be familiar with is the crest factor, which we may see in something like a compressor, and it describes the ratio of the peak volume over the RMS volume. And this type of measurement could even possibly give us a good transient detection system. But there is perhaps an even more specifically isolated way using the difference between two envelopes. And to understand this concept, we will first need to understand the basics of an envelope or envelope follower. And these terms describe a trajectory that follows the absolute waveform, but with some additional inertia or smoothing. And in an analog circuit, we would typically control this behavior with something like a capacitor. We charge the capacitor, and then it takes time to discharge, smoothing out the rises and falls, with something that's functionally equivalent to a variable RC or resistor capacitor low-pass filter. And I made mention of this in the last video too. So what exactly is the connection here? Lower frequencies take longer to produce a full cycle, or to rise and fall. So if we reduce the information to just lower frequencies, it takes a longer time for those frequencies to decay or build. And this is a way we might visualize how something like the attack and release on a compressor behave. So how would these help with transient detection then? Unlike a compressor gain reduction circuit, an envelope follower just enters the attack phase behavior whenever the signal starts rising, and the release phase whenever it starts falling. Short durations would give us behavior closer to a peak follower, and longer ones smooth out the smaller variances to capture mostly the large changes. So we can run the same signal through two differently timed envelopes and extract the difference. And that difference will tell us when we are in that region of the waveform, regardless of the signal level. Something like this, where a shorter peak follower and slower envelope capture just this information, ideally, regardless of the input level. And we can adjust the envelope timings to get something similar for detecting the sustain as well. I hope this provides some useful information on transients and transient detection systems. And be sure to check out Transient Reshaper, a new plugin from Psychocircuitry.